Greetings, everyone, and welcome to today's lecture of your musculoskeletal system course. We're going to be continuing with the histology portion, and we're going to be covering the histology of bone today. So just a heads up, I hope you guys watched the histology of cartilage lecture before you did this one, because some of the concepts in the histology of cartilage are similar to the histology of bone. So if you understood those concepts, then hopefully these ones are going to be easy for you as well. So let's go ahead and get started. Okay, so bone is what we call a modified type of connective tissue. It has all the similar components of connective tissue. It has the cells, it has the fibers, it has the extracellular matrix. And it has several functions, which include support and protection of vital organs. So if you think about the rib cage, it was made of the ribs and you have the vertebra at the back. Okay, so it protected the lungs and the heart and so forth. It's important, obviously, for attachment of muscles and ligaments, especially in the upper and lower limb and in the back and all the different places. And this is important also for movement. Bones are a site of storage for calcium salts in the body. So generally, whenever the body is in need of calcium, it tends to resorb the bone and then get the calcium from there. And you should also know from your previous courses that it contains the blood-forming elements. So basically, the blood cells and blood-forming elements are found within the bone. Now, there are several types of bone, and they're usually classified according to their overall structure, their shape, their size, their length, and just their general structure. And examples of the types of bone that we have are what we call flat bones. This has probably been mentioned before, especially when we took the thoracic cage. Remember, I mentioned the sternum was a flat bone. And this basically means that the two surfaces that make up the bone are very close together and there's hardly any space between the bone layers. You also have what we call long bone, or long bones, sorry, okay? And these are usually classified by having, or characterized by having, two ends, usually what we call an upper end and a lower end. And then connecting the two, we have what we call the shaft. And then another type of bone that we have is something called an irregular bone. Examples of these are the bones of the vertebral column, the small bones of the hand, the bones of the foot, and so forth. And generally, irregular bones just don't have a uniform structure, so they usually have like projections, and their shape tends to change in certain places. So they can't really be classified as anything but irregular. Okay, so we've agreed that bone, similar to cartilage, is made up of cells and extracellular matrix. So the bone matrix is considered any part of the tissue that is found outside the cells or in between the cells. My apologies. So the matrix is any part of the tissue that is found outside or in between the cells. And in the bone, there are two major components that make up the matrix. These are what we call organic, and this consists of collagen and elastic tissue. This provides the strength and flexibility of bone. And inorganic components are basically the minerals. So this mainly constitutes calcium salts, and what the calcium salts do is they make for the tissue hardness that is found in bone. So basically the characteristics of bone are drawn from the components of its matrix. You've got the strength and flexibility from the collagen and the elastic tissue, and you've got the tissue hardness that comes from the calcium. Okay, so that summarizes the matrix, which was anything found in between the cells. And now let's look at the different types of bone cells that we have. There are three types of cells that are found in bone, and each one tends to have a specific role. It has specific features so that you can differentiate the different types. Okay, now with bones or bone cells in general, you're going to find the prefix osteo. Okay, so the first type of cell is what we call an osteoblast. Now, these are usually cuboidal in shape. They are mononuclear, meaning that they only have one nucleus per cell. They are basophilic, which means that they tend to stain dark. And their function is to deposit the bone material into the matrix. So basically, the components of the matrix are produced by the osteoblast. Okay, so this is important for growth and for remodeling. So, for example, if there's like a damage in the bone structure and then it needs to be fixed, or the bone needs to change its shape with excessive movement or excessive stress or whatever, the components of the bone material are deposited into the matrix by the osteoblast. Okay, so this is what the osteoblast looks like. Like I said, it forms the bone matrix. Okay, it tends to have one nucleus. Okay, and then you can see here there are all the different types of organelles that are found inside the cytoplasm. Another feature of osteoblasts, oh sorry, this is just what they look like in in the histological section. So you can see them here at the end of the bone. Osteoblasts also have cytoplasmic extension. So if we just go back to the picture, okay, you can see here that there are a few extensions coming out of the cytoplasm. Now these are important because they allow communication with other cells. Remember, they have a role in growth and remodeling, and so obviously they can't function independently. They need to work together in order to make sure that whatever change happens correctly. Their cytoplasm also consists of actin and myosin filaments, which we saw when we took the histology of muscles. Remember, those were protein filaments that had the ability to change their structure and slide on top of each other and then cause movement. And the importance of having actin and myosin in the osteoblasts is that they allow the cells to move, so that they can go to the sites of bone growth and remodeling. So, for example, if you've got a long bone and the fracture is in the upper end, the aim would be that we need as many osteoblasts as we can focused on that region of the fracture, which is in the upper end. So we're going to want all the osteoblasts to kind of just concentrate themselves there, and so, or to be recruited to that region. So if they have the ability to move, then that means that we can take the cells from the lower end, from the shaft, and then just concentrate them in the region of the fracture. The second type of bone cell that we have is called an osteocyte. Now this is the part that I said that if you watch the video about the histology of cartilage, it's going to make a little bit more sense for you, and hopefully it'll be clear. These are osteoblasts that are trapped within the matrix they produce. So basically, they've already produced the matrix, they surround, or the matrix components surround the osteoblast, and when an osteoblast is surrounded by matrix, it becomes an osteocyte. They are generally elliptical in shape. They tend to have fewer organelles than the osteoblasts, and they tend to retain their cytoplasmic extensions. They do not produce matrix or undergo cell division. Okay, so an osteocyte, just basically think of it as an osteoblast that has the matrix around it. It's trapped within the matrix. I just had a little Keanu Reeves moment there. Okay, so here you can see the osteocyte. It has a single nucleus similar to the osteoblast. It retains or maintains its cytoplasmic extensions. You can even see that they're a little bit longer here than they are when it was an osteoblast. And they just basically maintain the bone structure. Okay, they don't produce any extra matrix, but they just maintain the structure as it has been formed by the osteoblast. Now, this is what the osteocytes look like. You can see that they've moved from the end of the bone and they're kind of found in the middle now, and they are surrounded by the matrix. Now, the last type of bone cell is what we call an osteoclast. Now, osteoclasts are the largest of the three cell types, and they are multinucleated. So the first two only had one nucleus. Osteoclasts tend to be multinucleated, and they can have up to 20 nuclei per cell. And they tend to have lots of mitochondria, meaning that they have metabolic processes that require a lot of energy, so that's why they have more mitochondria than the other two types. The function of osteoclasts is to break down the bone and allow stored calcium to be transported by the blood. So if you remember earlier, we said one of the functions of the bone is to act as a storage site for calcium. And whenever the body needs calcium, it tends to break down the bone components and release the calcium into the blood. So this is a function of the osteoclasts. Okay, so this is what the osteoclast looks like. You can see that it's larger than the other two cells that we saw earlier. It has multiple nuclei, so these are 5 in this cell, and it has lots of mitochondria. And as stated earlier, it functions in resorption and breakdown of the bone matrix in order to release any calcium that has been stored. Okay, and this is what the region of or an osteoclast looks like. You can see that it has a large size, larger than the other two. It has multiple nuclei, and then it tends to resorb the bone within the region of its immediate surroundings. Okay, so that concludes the first part of this lecture. Remember, it was just a summary of the structure of bone, the types of cells that you find in it, and the components of the matrix. And we also just really quickly mentioned the different types of bone. We're going to continue with the second part of this lecture in the next video, so I will see you guys then.